Welcome everyone to the machine learning project course. In this course, we are going to do the machine learning project for chatbot conversation using machine learning. So in the first class, we are going to discuss about how to import the packages and how to import the data set for our chatbot conversation. So in the second class, we are going to discuss about the concept of tokenization and natural language processing. In the third class, we are going to discuss about how to train the data set with the neural network model, and also we are going to discuss about how to save the neural network model for our project. So in the final class, we are going to discuss about how to create the conversation between the user and the chatbot using the trained model. So this course is very useful for the students who are trying to create chatbot conversation using machine learning for the first time. And also you have to familiarize with the Google Colab and also with neural network. Let's see you in the course taught by me. So let's get started. Welcome everyone to the first class. In today's class we are going to discuss about how to create a new notebook in the Google Colab, and also we are going to discuss about how to import the packages for our project chatbot using machine learning. For executing our project, we have to create an account in the Google Colab. After creating an account in the Google Colab, you have to create new notebook in the Google Colab. For that, you have to select the file. So in the file, you can see new notebook option. You have to select that. After creating the new notebook in the Google Colab, you have to type your project name. So you have to type your own project name, whatever you want. So we are going to type chatbot using machine learning, that is ML. So we are going to type chatbot using machine learning. After typing your project name, you have to select runtime. So in that you have to select change runtime type. So you have to select any one of the options. We are going to select the T4 GPU for running our project. After that you have to select OK, and then you have to select Python 3, and then you have to select save. So you can also see T4 GPU is connected for our project. So these are all the first step for creating our project. So after that we are going to discuss about how to import the packages for our project. So you have to type import numpy as np. So numpy for creating the array. After that we are going to import the second package, import JSON. So JSON for the conversation dataset between the user and the chatbot. For that only we are going to use the JSON package, and then we are going to import the third package, that is TensorFlow. So we are going to use the TensorFlow package for our machine learning project. These are all the important packages. So after that we are going to import the other packages from TensorFlow. From the TensorFlow main package, we are going to import the sub package, that is Keras. We are going to use the Keras for training the TensorFlow model. For training the models, we are going to use the Keras. After that, we are going to use the other package from TensorFlow. You have to type correct TensorFlow dot Keras dot model. From the main package, we are going to import the sub package. So the sub package is import. We are going to import the sequential model. So we are going to use this model for our chatbot using machine learning project. For that only we are imported that package. After that we are going to use the TensorFlow again. TensorFlow dot Keras dot layers import the sub package dense. So dense is nothing but layers for our project, and then embeddings. So embeddings converts the input into fixed size. and then global average pooling to 2D. So we are going to use this subpackage for our project. So dense for the 2-layer, and then embedding for converting the integers into fixed size, and then global average pooling 2D for finding the average values of our project. And then we are going to import the tensorflow.keras.preprocessing.text. So we are going to extract the features of the text, and then we are going to import the subpackage, that is tokenization. So tokenization is nothing but it converts the words for the machine to understand the human language. After that, we are going to import the keras.preprocessing.sequence, and then we are going to import the subpackage import pad sequence. So pad sequence is nothing but it converts the sequence of words from 0 to 9 or 0 to 10 or 0 to 11, from 0, 1, 2, 3, that's the sequence. At last, we are going to import the last package, that is scikit-learn package. From that, we are going to import the subpackage, that is label encoder. So label encoder is nothing but it converts the words to numerical format, that is animal to 0 or animal to 1. So that's the use of label encoder. Or all the packages must be installed for running our project. NumPy for array, JSON for the dataset, TensorFlow for training our project, and then Keras for training the model of the TensorFlow, and sequential is the model used for our chatbot, and then dense for the layer, embeddings for converting the integers to fixed size, and global average pooling 2D for finding the average values of the training, and then tokenization for the machines to understand the human language, and pad sequences for the sequence of numbers, and label encoder for converting the words to numerical format. So you have to run this code. After that, you can see all the packages are successfully imported for our project. So that's it. In today's class, we have discussed about how to import the packages required for our project chatbot using machine learning. In the second class, we are going to discuss about how to import the data set for our project. So let's see you in the next class. Welcome everyone to the second class. In today's class, we are going to discuss about how to import the data set for our project chatbot using machine learning. For the data set, we are going to use the JSON file. So you can see the JSON file is created for my project. So you have to open that using any one of your IDE. We are going to use the Notepad++ for opening our JSON file. So you have to select that. So in that, you can see there are predefined conversation between the user and the chatbot. So these are all the predefined conversation useful for our project chatbot using machine learning. So there are many conversations between the user and the chatbot. If the user says goodbye or bye, see you later or goodbye, and the chatbot will give that response like see you later, have a nice day, bye, and come back again. So these are all the predefined data set for our project. We are going to train these predefined conversation for our project. So after that, you have to import the JSON file in your Google Colab. So you have to select import option, and then you have to select your JSON file. So you can see your JSON file is imported in the Google Colab. You have to type this code for importing the dataset with open off. Inside that, you have to type your JSON file path. You have to copy the path, and then you have to paste inside the single quotation as file. We are going to open the JSON file. After that, we are going to load the file for our project. For that, you have to type data equal to JSON dot load of file. We are going to load the JSON file for our project. After importing the dataset for our project, we are going to create arrays for our project. First, we are going to create the training sentence array. So you have to type training sentences equal to array. And then we are going to create the second array, that is training labels. So we have to create the array. After that, we are going to create the third array, that is labels, and then responses. Last array will be responses. So these are all the arrays we have created for our project. For training the sentence, for training the labels, and then labels and the responses. So these arrays must be created for the JSON file. So after that, you have to type for loop for intent. So you have to type intent in data. So intent will be the iterating variable. Inside the data, you have to type intents. So you have to type correct intent. So you have to create an for loop. Inside the for loop, you have to type for pattern in intent. So we are going to find the patterns. So you have to create patterns. So inside the for loop, you have to type training sentences. Training sentences. So you have to check training sentences dot append of pattern. So if we find the patterns in the intent JSON file, we are going to append that file to the array created of training sentences. After that, we are going to type training labels dot append of intent of tag. So these are all the columns available in the JSON dataset. So you can see the tags, patterns and responses. For that only we have created the arrays for storing these values. Intents is the first line. Intents is the first column, and the tags, patterns and the responses are other columns in the JSON dataset. So for these columns, we have created the array for storing that. So that's the use of the for loop. For every columns, we have created the array and then we are storing the column values inside the array. And then responses. Responses is the last column in the JSON. We are appended the responses with the intent of responses. We have created the response array for storing the response column values. So these are all the columns available in the JSON file. Tags, patterns and responses. So we are storing the values of the columns for the arrays. We have created training sentences, that will be the pattern. Patterns are training sentences. Labels for the tags and responses. So that's the use of the for loop. At last we are going to create the if condition. If intent of tag not in labels. If the tags are not available in the labels, labels dot append of. So inside that you have to type intent of tag. So we are just using that. If the labels are not present, we are just append the values of tags. So we are using the if condition for appending the tags for the labels. So tags are nothing but goodbye, thanks, about, name and help. So that's it. We have created the data set for our project, and then we have created the arrays for our project. After that we have created the we are appended the values of the columns inside the created array. So after that, at last we are going to type the number of classes equal to len of labels. Each labels are considered as classes. Labels are considered as tags. So the tag greeting is the first class. Tag goodbye is the second class. Tag thanks is the third class. So labels are nothing but tags in the JSON file. So that is nothing but the classes of our project. So in the next class, we are going to encode our code for our project. So let's see you in the next class. Welcome everyone. In today's class, we are going to discuss about how to encode the labels for our project. Because our output requires the integer format. For that only, we are going to convert the labels to the numerical format. That is, we are going to convert the tags like greetings, goodbye into 0, 1, 2 and 3. For that, we are going to discuss that how to encode the labels. You have to type label encoder equal to, so that's the variable, and then we are going to call the label encoder function. Yes, we have just created the function. After that, we are going to use the label encoder variable dot fit. So we are going to fit that training labels. So we are just converted our training labels to the numerical format. Training labels array will be converted into numerical format. So that's the use of label encoder. And then training labels, training labels equal to label encoder dot transform of training label. You have to type training labels. We are going to convert the labels into encoder format. That is the numerical format. So in the training labels, array consists of the labels like greetings, goodbye, thank you. That will be converted into 0, 1, 2. So you have to run this code. So you can see, you can see all the values are completely changed into numerical format. So in today's class, we are discuss about how to encode the labels. In the next class, we are going to discuss about tokenization. Welcome everyone. In today's class, we are going to discuss about the tokenization for our project. So tokenization converts the words to the machines to understand the human language. It converts the sentences into words for the understandable machine language. So we are going to see that how to type the variable vocab size 1000. So it can be your own choice. The maximum sentence input will be 1000. And then embedding. So you have to type correctly embedding dim equal to 16. After that you have to type maximum length of the input will be 20. So the user input maximum length is 20. And then we are going to use the OOV token. So OOV token is nothing but out of vocabulary. So it is very useful for the natural language processing of our project for finding the meaningful words for the machines. And then you have to type the variable tokenizer equal to after that you have to type the function tokenizer of inside that you have to type the values like number of words can be number of words equal to vocab size, that is 1000. The number of words will be 1000. And then OOV token equal to OOV token, that is 00V. So we are going to use the tokenizer variable dot fit on text. We are going to use the tokenization for our text, that is the array training sentences. So the training sentences contains the sentence of our project. So we are going to use the tokenization function in the training sentences variable. So the training sentences contains the sentence of our project. We are going to find the meaningful words for the machines to understand from the training sentences. And then we are going to find the index, word index equal to tokenizer dot word index. We are going to find the each word index, that is 0, 1, 2, 3. And then we are going to convert the sequence of words, that is I teach machine learning. I is the first sequence, teach is the second sequence, machine is the third sequence, learning is the fourth sequence. So for the meaningful sequence of words, we are going to use that function, text to sequences. So that's the use of the sequence. Without the sequence, the machine cannot understand the process. So we are going to convert the sequences for our training sentences. Tokenization is nothing but finding the meaningful words for the machine to understand our language. And then padded sequences equal to pad sequence. So it's same as finding the sequence of the words. Sequences. We are using the padded sequences. Inside that we are going to use the variable sequences. And then truncate equal to post. After the function, we are using the post variable. We are not using the pre, we are using the post. And then we have to type the maximum length, max length equal to 20, that is the max length. So we are just to predefine that it will be 20. So the sequence of input will be 20. So the user gives 20 words of sentence. So that's the limit of the max of length. So first we have created the vocabulary size and then embeddings 16 and then maximum length, max length equal to 20, and then OOV token for the natural language processing. Also the full form of OOV is out of vocabulary, and then we are finding the tokenization. So we are applying the tokenization in the training sentences array because the training sentences contains the sentence of our project. And then we are finding the index of each words in the sentences. After that, we are finding the sequence of the words. I teach machine learning 1, 2, 3, 4. And then we are using the padded sequence for the maximum length and truncating. So these are all the concept for the tokenization of our project. For finding the tokenization, you have to use the tokenizer function and then index and sequences. So you have to run this code. So after that, you can see our tokenization is run successfully. So in the next class, we are going to discuss about how to train our data set using the neural network. So we are going to discuss that. So let's see you in the next class. Welcome everyone. In today's class, we are going to discuss about how to train our data set using the neural network. For that, we are going to discuss that. You have to type this code. Model equal to sequential. We are going to use this model for training our project. Sequential model. After that, we are going to add the layers and embeddings for our project. First, we are going to add the embeddings for converting the integers to the fixed size on the training process. It will not change during the process of training. For the integers like vocabulary size is 1000, and then embedding dim. So embedding dim is nothing but 16. And then input length. So input length, it is the maximum length, that is the 20. So these are all the integers which can be fixed using the embedding function. So it will not change during the process of training. Fixing the values of the integers, you have to use the embedding function. After that, we are going to add the layers. First, we are going to add the global average pooling 2D. Not 2D, we are going to use the 1D function. So 2D is not useful for our project. We are going to use the 1D. Before that, you have to change the package also. So you have to change the package. You have to type, instead of 2D, we are going to change that to 1D. After that, you have to run the packages. So that's it. And then you have to add the layers. So the global average pooling 1D is very useful for finding the average values of the training process. And then we are going to add the dense layer, dense of 16. Activation equal to RELU. So RELU is very useful for activating the layers in each training process. So there are many layers available in each process of the training. For that, we are going to activate them using the ReLU function. Because our neural network consists of many layers. For activating that layers, we are going to use that function ReLU. ReLU. And then we are going to add the dense layer of number of classes. So the number of classes is same as the number of labels. And then we are going to use the activation softmax. So softmax is very useful for, it classifies the classes in our project. If you have 2 more classes or 3 classes, it classifies each class, the first class, second class and third class. For that only we are using the softmax. Softmax is very useful for classifying the classes in our data set. And then we are going to compile our model. So we are using the loss of spare categorial. So you have to type categorial cross entropy. So this function is very useful for minimizing the loss of our project. So if you want to minimize your loss, you have to use that. And then we are using the optimizer. So optimizer is nothing but optimizes our training process. It optimizes the accuracy, prediction, and the training losses. For that only we are using the optimizer. So for our project, we are going to use the optimizer, that is Adam. We are going to use the optimizer Adam for our project. Comma, and then metrics equal to accuracy. So accuracy is our metrics. We are going to find the accuracy. So after that, we are going to use our model to the summary of, we are going to find the summary of our project. And then epoch can be your own choice. We are using the epoch 20. And then history equal to model dot, we are finding the history of our project. Fit of padded sequence, comma, np dot array of, we are creating the array for the training labels, dot epochs equal to epochs. So that's it. We have completed the training process of our project using the neural network. First, we are using the sequential model for training the project. And then we are using the embedding for the fixed length of the integers. Integers like vocabulary size, embedding them, input length, maximum length. And then we are using the global average pooling only for finding the average values. And then dense layer, we are adding the dense layer of our project. And then we are activating the lens. And then we are activating the layer using the ReLU. And then we are using the classes with the activation of softmax. Softmax is used for classifying the classes in our data set. After that, we are compiling our model using the optimizer Adam and then spare categorial cross entropy. At last, we are using the epochs for our project. Epochs can be your own choice. Before that, you have to type the sparse categorial cross entropy. That not spar, that is sparse. You have to add yes. So we are compiling that. So you have to run this code. So you can see our model is training with the sequential model. So you can see the 20 epochs are trained with the accuracy of 0.15. If you want more accuracy, you have to increase the epochs. So if you want to increase the epoch, you have to type your own values. We are going to use 100. So you can see 100 epochs are training for our project. So you can see all the hundreds are trained with the accuracy of 0.2. For this project, you have to use the epochs of 500. So that's it. In today's class, we have discussed about how to train the data set with the neural networks. So in the next class, we are going to discuss about how to save the model trained using the neural network. We are going to discuss that in the next class. So let's see you in the next class. Welcome everyone. In today's class, we are going to discuss about how to save the trained model using that neural network. For saving the model, you have to type this code, model equal to, so you have to type model dot save of. Inside that, you have to type your file name, chat, your own file name or your own folder name. We are going to use the chat folder. Inside the chat folder, our model will be saved. Before that, you have to use the important package for saving the trained model. We are going to import the pickle package for saving our model. For that, you have to import the pickle package. So you have to type pickle, P-I-C-K-L-E. So you have to import this package for saving the model. And also you have to type the functions which are useful for saving our model. You have to type with open of tokenizer dot pickle. So this function is very useful for saving our model, comma, the format will be WB, writing format, as handle. We are saving this as handle. So this function is useful for saving our model, and then pickle dot dump. So we are going to save that using the dump function, tokenizer, comma, handle, comma, and then protocol. We are going to use the protocol for saving our model. The protocol will be highest protocol. Highest protocol. So we are going to use the pickle highest protocol for saving our model. And then we are going to use the second function for saving our model. You have to type with open of label encoder dot pickle, comma, it also same as write format WB, as you have to type the name ENC file, ECN file. ECN file is nothing but encoder. So you can type your own name, whatever you want. So after that you have to type pickle dot dump for saving the files dot tokenizer. So inside that you have to type label encoder. You have to type label encoder, LBL encoder, comma, ECN file, comma. Again you have to use the protocol. So the protocol is same as protocol equal to PROTOCOL equal to pickle, PICKLE dot highest pickle, highest protocol. So these two functions which are required for saving our trained model. So pickle package is useful for saving our model. So you have to run this code. So you can see all the files are saved in our Google Colab. Tokenizer pickle. Inside the chat folder you can see the saved model of our project in the PB format. So keras model, keras metadata, fingerprint, variables, label encoder. So these are all the files saved from our trained model. So that's why the pickle package is very useful for saving our trained model. So in the next class we are going to discuss about how to create the conversation for our project ChatBot using machine learning. So we are going to complete our project in the next class. Welcome everyone. In today's class, we are going to complete our project ChatBot using machine learning. So in the today's class, we are going to see about how to create the conversation between the user and the ChatBot. Before that, you have to import some of the important packages for our project. First, we are going to import the Colorama package. Colorama package. So for the colors in the GUI of our project. So you have to import the package, and then you have to use the package, main package, dot initialize. We are going to initialize that package. And then we are going to import the sub package from the main package. Colorama import font import for styles and background. For that you have to type back, front color, back color and the styles. And then we are going to import the last package, that is random, for the chatbot for creating the random conversation. You have to import that, you have to run that. Before that, you have to check whether the package are installed for your project. So you have to import the packages for your project. So you have to type pip install. So you have to type the code for installing the packages. So the common code for installing the package is pip install and the package name. Before the pip, you have to type the symbol for running the project in the Google Colab. For the normal process, you don't have to type the symbol. So after that, you can see the packages are installing in the Google Colab. So all the packages are successfully installed. So we are going to do our conversation for our project. So you have to type with open off. Inside that you have to type the dataset name, that is the JSON file path. And then as file. We are going to open that file and then we are going to load the file. JSON dot load of file. We are going to load the file in the Google Colab. So after that, we are going to create the function for our chat. So inside the function, you have to type the code for the chat process. You have to type model equal to keras. We are going to load the keras model. Models dot load model of. Inside that you have to type your model name, chat. So inside the chat folder, you can see your model. So first we are loading our model, keras model. And then we are going to use the tokenizer pickle. So we are going to open the tokenizer pickle. So inside that you can type tokenizer dot pickle, comma. We are going to read the file. That's why you have to type RB format as handle. So you have to type pickle. So you have to type tokenizer equal to pickle dot load of handle. We are going to load the pickle file in the readable format. After that, we are going to import the label encoder pickle file. So again, you have to type the same code, label encoder dot pickle, comma RB in the readable format as. You have to type your file name ENC, and then you have to use the label encoder to load your pickle file equal to pickle dot load of encoder ENC. First we are imported the model and then we are imported the pickle files. So after that, you have to type the maximum length equal to 20. Our input length, maximum length is 20. User can give the input of 20 values only. And then we are using the while function, while true. Inside the while, you have to type the code for the conversation. Print four. So that's the foreground color. Foreground color will be light blue. So the user input color will be light blue. And then you have to type the own value, user or creator or author or admin. You can type your own words and then style reset all. Dot reset all. So this is the input for the user. So you have to type 4 dot light blue. So the user input will be light blue. And then you have to type int. Input will be the variable for input of the user. So after that, we are using the conditional values. If the input dot lower of. So the input will be converted into lower form. If the input of the user is quit, we are going to finish our conversation with the chatbot. So that's why we are using the break. And then if the input user is not quit, we are going to predict the model of the user input. So we are going to predict the model using the keras dot pre-processing. We are pre-processing the text of the user dot sequence. We are converted into the sequence, and then we are finding the sequence input of. Inside that, you have to type the tokenization. So you have to type tokenizer. We are finding the tokenizer of the words which are understandable to the machine language. So and then we are converted the words to the sequences. So inside that, you have to type the input. So we are finding the tokenization for the input of the user. Comma, truncating equal to post. After the typing of the user, we are finding the values. That's why we are using the post function. And then maximum input value will be 20. So that's why we are using the max len. Max len is 20. So that's it. So we are just finding the input value of the user using the tokenization. And then tag equal to label encoder. Dot inverse transform. So we are finding the values from the inverse form. And then we are converting that array arguments. Maximum argument will be the result. If the result is founded from the inverse form, it will be used for the tag. After that, you have to type the for loop for I in data of intents. So that's the column in the JSON file. So inside the for loop, you have to type the code for each columns. If I tag. Inside the intents, you can see the tag. So the user input tag will be compared to the intents JSON file tag. If both are matches, the chatbot will give one response to the user. So that's the meaning of the for loop. First, we are finding the intent column, and then we are checking the tag of the user and then tag of the JSON file. Both are matched. The chatbot will give a response in the green color. For that only we are using the green chatbot style dot reset all and then random choice. Inside the response, you can see there are 3 columns available. So the chatbot can select any one of the files based on its own choice. So that's the use of the random choice. Random choice of I of responses. So responses contains 3 values. So the chatbot uses any one of the values for the user input response. After that, we are going to print the welcome message in the yellow color. So you have to type print 4.yellow. You can type your own message. You can type start message, or you can type welcome to the chatbot conversation, or you can type welcome message, whatever you want. And then style reset all. And then we are calling the chat function at last. So that's it. We have completed the conversation between the user and the chatbot. First, we are imported the JSON file. After that, we are imported the Keras model from the chat folder. In the chat, you can see the model, and then we are imported the tokenizer pickle and label encoder pickle in the readable format, and then maximum length of the input is 20. After that, the user gives the input. So if the user input is quit, it will be breaked between the conversation. So after that, the user input is converted into the tokenization for finding the meaningful words for the machines. After that, we are finding the tags from the result. So if the tags of the user and the tags of the intent JSON file are compared, if the both tags are equal, the chatbot will give one response in the random choice. So the tag greeting. After that, we are calling the chat option to complete the process of conversation. So you have to run this code. So you can see our output is successfully executed. After that, you can type your own word. For that, first I'm going to type my own words and then I'm going to press enter. So in the output, the chatbot gives hello message for my hello message. So our chatbot is well trained with the conversation. So after that, I'm going to copy any one of the conversation, whether the chatbot gives correct response or not. So we are going to copy the hey from the conversation, and then I'm going to paste that. So the chatbot gives correct response for my conversation from inside the response values. So after that, you can also copy other conversation from the JSON file. If I type hi, also it gives hi there from the responses. After that, I'm going to copy any one of the conversation from the JSON file, and then I'm going to paste the conversation in the chatbot. So you can see the chatbot gives correct response based on the predefined responses in the JSON file. That is, it is well trained with the neural network. So you can type your own words or you can type your conversation from the JSON file. After typing, you have to type enter. If you want to exit your conversation, you have to type quit. So you can see our conversation is ended with the chatbot. So that's it. We have completed our project successfully. So in the first class, we are discussed about how to import the packages. In the second class, we are discussed about how to import the data set. So after that, we have created the arrays. After that, we have discussed about how to encode the tables. In the fourth class, we have created the tokenization for our project. So in the fifth class, we have trained our data set with the neural network. In the sixth class, we have discussed about how to save our trained model using the pickle package. At last, we have discussed about how to create a conversation using the trained model for our project ChatBot using machine learning. So you can also see the output for the ChatBot conversation. So our project is completed successfully. Hope you learned something from this project. Also, you have to familiarize yourself with the Google Colab for training your project with the free GPU. Also, you have to familiarize with the chatbot conversation, and then you have to familiarize yourself with the neural networks. So if you like my project and also if you like my course, please put positive review in the comment section. Hope you learned something from this. Hope I can see you in the upcoming courses taught by me. Thank you.